Good morning, guys. Hope you're all well. Welcome to another video on Python fundamentals, and we are continuing our functions and methods series. In this video, we're going to talk about a very special technique in programming that deals with functions. We're going to talk about recursion. All right, it's going to be quite a short video because we have, I guess this topic is it's quite hands-on. So we're going to move to Visual Studio soon. So let me just give you a breakdown of what recursion is. So let's not forget, what is a function? A function is essentially a piece of code that is used to perform a single related action. And you remember, we usually have an input, which can be an argument, right? The argument is what replaces the placeholder, otherwise known as the parameter. And those arguments are manipulated in the process. We carry out some instructions based on what we want, all right? And then we output that back to the user as a result. Sometimes we can just print out something to the screen, or we can return a result of an operation and store it as a variable. And we can store it as a variable. So what is recursion? Recursion is a technique where a function invokes itself, right? And usually it's used to create clean and elegant code, because you can just write something that would take you a bit more chunky code, where you would otherwise be using like a for loop or a while loop. You could just write a recursive function, and in 2 or 3 lines, then you're done. However, if there is no base case, usually referred to as the terminating condition, you could run the risk of your function entering into an infinite loop. And this is quite memory intensive and can, if you're not careful, can cause your computer to crash. Now, so just below we have a function called fun, and it takes in a parameter or an argument n, which is a value integer. And it says if n is equal to 0, return, otherwise print hello world. And then we run that function again while decrementing n. Okay, we will show you this in the Visual Studio Code examples, how it works, and I'll also draw some tracing trees, recursion tracing trees, that will help us to trace how the recursion function is operating. So just to round up some advantages and disadvantages of recursion. So it's used to create clean and elegant code, like I said. So, and secondly, complex tasks can be broken down and simplified using recursion. You don't have to write numerous lines of code just to solve a problem. You can just break it down to a recursive function, and that will be it looks quite simple. All right. Sequence generation is simpler with recursion compared to nested iterations. Remember, I said you can create clean code and simplify tasks. So that is one task that can be simplified. However, we have disadvantages. So the logic behind recursion can be hard to follow. However, we're going to draw some recursion tracing trees just to assist us with how we can follow the recursive function. And then recursive calls are expensive and take up a lot of memory and time. That is a big disadvantage. So just be careful how you use recursive functions. If you can write it in a simpler for loop, then you don't necessarily, or a loop statement, you don't necessarily need to use recursion. And then finally, recursive functions can be difficult to debug. All right, remember that. So we're going to go through some examples of recursion using the Fibonacci sequence and the factorial. So the Fibonacci sequence is just a sequence in which a number is the sum of the 2 preceding numbers. And so usually the common way that the sequence starts is either between 0 and 1, 1 and 1, and 1 and 2. And I don't know if you've heard of the golden ratio, but this is just an example of that, right? And there's just some definitions of the sequence. So for whatever index that you have, it's essentially the sum of the 2 preceding numbers, excluding the first 2, 0 and 1, right? Yeah. So n is greater than 1, all right? So let's continue. And then the factorial, it's just where, as you can see, I've written down the formula for the factorial, and we'll give an example of just 6. So you just take every number up to 6, from 1 to 6 to that number, multiply, and then you'll get the factorial of that number. So finally, just some takeaways. Remember, recursion is where a function invokes itself in the function call definition, right? Recursion is used to create clean, elegant code. It can be memory intensive and can be hard to debug. All right, guys, this is just a quick short slide presentation. Let's move over to Visual Studio Code. I'll see you guys there later. Cheers. Good morning, guys. Welcome back to recursion. All right. Now, I want to talk about something quite interesting called function of control. All right. The control flow of a function. Let's quickly define functions. It's just going to be just to demonstrate something. I'm calling a function called called func, and I'm going to create a value called create a variable called val and store the number 25 to it, and that this function just returns val, right? That is all, And then I'm going to run another function called test, and what this does, what happened there? All right. What this does, I'm going to say print, so ul, all right. And then I'm going to say x is going to be func, right? And I'm going to say y is going to be 15, okay? And then I'm going to do something called result, all right? It equals to x plus y. And then I'm going to return the result. I was going to say return the result, but yeah, that's not how we do things. Yeah, okay. So let me just explain what is going to happen right now. All right, so now I have, okay, I'm going to say test result, or let's call A is equals to test, right? And then, I don't want it to give us the answer. I think it just did if you saw it there, but let us, let me explain what is going to happen, right? So I'm invoking this function test, right? And then what happens is when I invoke it, right? Well, it's not necessarily going to print it out now, is it? Now, when I run it. Actually, it might. It probably will. It would, yes. When I run it. So it's going to print this out, okay? And then I'm going to get here to line 8. And then what it's going to do is going to exit this function test and go into this function, right? It's going to say val, right? Then it's going to return val and then as 25 and then store it to x, and then it's going to continue, right? So it left our function for a bit, went to this function. Okay, so this is what's going to happen. I want to get the val as 25, and then I am going to store you as to this variable called x. And then from there, we do this operation, right? And then 15 plus 25 should be 40. If we run that, we say Python recursion.py, right? Okay, well, we didn't print A. So that's why it's not showing us the answer. So we can just do that again. And yes, we get our UL. Add 40. All right, it's 3 a.m. So but let's learn some. Let's get to it. So this is just something I just wanted to show you about function of control. And if I was to, let's see, if we were to do something, let's do this, and then let's do plus that, right? So what's going to happen now is, right? So when I get here, I'm going to exit this function, go there, fetch my value of 25, and then this is going to become 25. Then I'm now in this function. I'm now going to do this operation, and that's going to be 50. If I'm not, my mathematics is still awake. And then I'm going to say 50, right? Plus 15 plus 20. Then I'm going to exit the function. Then I'm going to fetch that, and it's 25. So that's going to be 50, 65, 90, right? And then we're going to run it again. And there we go. All right, so I just wanted to show you this. Then we can move on to the recursion. We're going to draw some recursion trees, tracing trees, and see you there right now. Coolio. Okay, guys. All right, so I'm going to start with a quick function, right? And I am going to write define rec, right? And it's going to take us, let's call it n, right? And then I'm going to say if n is equals to, actually, you know what? If n, what I'm going to say is print hello world. You know, let's say print hello world, and then we're gonna say rec, right? So this is an example of a recursive function. I'm just gonna remove this now, and then so what's gonna happen is this function, right? And if I invoke it here, what's gonna happen when I call it, essentially, it should just print hello world, right? Remember when we're talking about recursion and I said there always has to be a base case, a terminating condition. But if you look here, I haven't put anything first. So I just want to show it just for illustrative purposes. Fortunately, Python has a safety check where if you enter a loop, a recursive loop, and it sees that there's no terminating condition, I think after 500 iterations, it will stop. All right, cool. Let us terminal. Let us clear our previous workings. And there's no such thing as layer, it says clear. Cool. And then we're gonna run, and there we go. It's just going, and then boom, we had a recursion error, right? We'll get to these type of errors and how we handle them in Python. Okay, I guess it's not 500, 900, more than 900, right? Times. So I think it's 1,000. There we go. Okay. So now let us create a terminating condition, right? I'm going to put in a number, n, which we could think of as a count, right? And then what we're going to say here is if the n, the count, is equals to 500, we just want to test 500, right? Return. So we're going to exit the function. That's our terminating condition, right? Exit the function. Just remember the return immediately stops the execution of the function, right? And then, so we have to do something. We have to change n, right? So we're going to do n. We have to like increment it, right? So that n just doesn't stay whatever number that we put it. We have to increment it. All right. And so I am going to then give it a value of 0. And that should increment. And then if I run this, and there you go. And it ran for 500 times. Okay. And if you even wanted to see that, we could even say hello world. And then we could put n here and then see how many times. So this would be telling us how many times it's run. We can just do that. 500, 02499 is 500. Okay. So I want to show you how this function is actually working. And I'm just going to remove, it's called a tracing tree. Let's draw a tracing tree for this function. Okay, I'm going to remove that and just put n. And then we're going to change this a bit. It's going to say n is 0. So now we're going to decrement the count. So whatever number I put in, I'm going to decrement it. So we're going to start at just 3. Okay. And we can see if we run it, it just prints n 3 times. No, 3, 2, 1. Okay. And remember, when it goes to 0, it exits the function. So I'm just going to show you a tracing tree on how this works. Okay. So we are on a Jamboard, right? And this Jamboard is essentially just going to show you, I'm just going to draw the tracing tree, okay? There might be a bit of a lag. I'm drawing from another device, okay? But let's get to it. So we have the function rec, right? And we call rec 3 times, right? And then we're going to, right? So remember it says if n is equals to 0, return, but n is 3. So we're just going to, we're going to say print 3. Then we're still in our recursive call, and it's now going to be rec 2 minus 3 minus 1, which is 2. So it's going to be rec 2, right? And then when we get to rec 2, what is n now? N is 2, so we print 2. Then we have another recursion call. It's going to be rec 1, right? Then we're going to print p1, and then we get to what's 1 minus 1. That is now 0, so we exit our function. So then what happens is now that we've gotten to the end here, we now go back to rec minus 1. We see, was there anything below rec minus 1? No. Okay, cool. So we continue. Was there anything that we had to execute after rec2? No. Then we end at, and then that's the end of the function tracing tree. Okay, guys? So, all right, guys, just made a minor adjustments just to illustrate what's actually happening. So let's start from the top. Rec3, right? We print 3 there. We print 3, and then from there we go to rec2, where we then print 2. Okay. Then from there we now have another recursive call, rec1, right? And then we print 1. Then we have rec1 minus 1, right? We're still going to call this, but then we now see that our terminating condition is our terminating condition. 1 minus 1 is 0, so therefore n is 0, then it'll exit. And then from rec minus 1, we have to go back and check if there was anything that we needed to execute below. Nothing. Then we continue, and we continue to the top, and then we end the function. Okay. We'll do another example just now. See you there. Okay, so now we're gonna do another one. We're gonna write another function, another example, recursive example, and I'm just gonna copy and paste that, and I'm just gonna change it to 2. We're still gonna have the same terminating condition. However, this time, what we're gonna have something that executes after the recursive call. Right, I just want to show you what happens there, and that's gonna be 2, right? And then I'm going to invoke it again. Then I will now show you a tracing tree. All right, so we call you, and there we go, 1, 2, 3. All right, different from the other one. So I'll just show you how that works. See you there now. So we're gonna have rec2, right? And it is going to be, that's our first, we're starting at rec2. Then we have a, now you see, we check is n equals to 0? No, it's not. So we continue. So okay, we have another recursive call where we decrement n. So that's now gonna be rec2, and it's going to be 2. Okay, then we, all right, called it again. So now we're going to decrement. So now we get here, we're going to decrement it again. So that's going to be now rec. That should be a small n r, not a capital. Rec2, 1. Then we go down again. Then from there we have rec 2, 1 minus 1, and this is the terminating condition. So we end there, and then so that ends there. So now we have to go back here. What do we have? So there was something below here, but n is 0, so but we don't get to that point because we exit. But then we get to here, and then there's rec 2, 1, but then we have a print n, and then we're gonna get 1. All right, that's what the first thing we should print. Then we're gonna get here, we're gonna go back, and that should be p1, sorry. So small k. Then we're gonna go to rec2, and okay, well, we still have that print below, and it's gonna be p2, and then we're gonna get p3, right? So that's how it works. So gonna get 1, 2, 3. All right. If I'm not mistaken, that's what we got in our Python recursion, you see? So that's the order. So it's going up like that. That's the order of the execution, okay? And I'll show you another example of a tracing tree. We have the third version. We have the same base condition. We take the same parameter n. However, we have something before our recursive call and after our recursive call. So I just want to show you how that will look like. Okay, guys. Welcome back. So let's start again. So it's going to be rec. It's going to be rec 3 of 3. All right. And then we're going to print ul. Right. So we're going to have ul. And then we're going to have a recursive call of rec 3 of 2. All right. Remember 3 minus 1 is 2. Then remember, so enter the function again. It's now going to print ul. Then we're going to have rec 3 of 1. We're also going to have another ul, right? And then we are going to have our rec 3 of 1 minus 1, and that is terminating because that becomes 0. And then, remember, like I said before, we're going to move up here, and we're going to have another ul. Then we're going to go back up, right? We're going to have another ul, because there's something below that, and we're going to have another one, go back up, and it's going to be another UL. Right, so it's going to be in the order of, so this is going to be the first print, 1, 2, 3, 4, 5, and 6. All right, guys. So this is just some tracing trees for recursion. And let me draw some arrows here to make sure that we are clear on the matter. Okay. See you guys when we get to our factorials and the Fibonacci sequence using recursion. Cheers.